This is 9.1 day 2, part 2. Just finished up example 2 here. So just want to show you all that work in case it was a little rushed for you. And I didn't do such a great job connecting the dots there, but I tried my best. Running through those same 4 steps over and over again. So finding that axis of symmetry, using that value to find my vertex, taking my y-intercept, which is always just that number on the outside there, reflecting it, and then factoring for my x-intercept. So I have 2 more examples, and these are a little tougher in terms of there's more than just a 1 for my a value, and that's also going to affect my factoring as well. So take a look at example 3 here. Again, something helpful, I think, before you begin is to identify that a and b value. It helps to identify them before you plug them into something. So this time, notice, look what's in front of x squared, a -1. A is -1. It's going to make a huge difference. B is a +6. So when I go to do my axis of symmetry, x equals -b over 2a, I'm plugging in negative b is 6 over 2 times -1. This is going to simplify a little different than the last couple, right? So I have -6 over -2 gives me a +3. So my axis of symmetry is x equals +3. I go to 3 on the x-axis. Don't put a dot on the x-axis, just sort of start to draw your vertical line from that point on the x-axis. And what's great is I've now found my axis of symmetry. That's the x value for my vertex. My vertex has to be on that axis of symmetry. So I'm going to take my function and I'm going to plug in 3 for x. Now, my function is negative and then x squared. So that negative is completely independent from the x squared. I put parentheses for the x, not for what's in front of it. So negative and then something squared plus 6 times something minus 5. And then I plug in a 3 inside those parentheses. So f of 3, notice the change here. This is not -3 that I'm squaring. I'm squaring 3, and then I happen to have a negative out in front. So 3 squared is 9 times that -1 out in front is -9. If you type it in exactly as you see it here, your calculator will say -9. If you type it with that negative inside, your calculator will say +9. It's all about what's being squared. Is the 3 being squared and then there's just a negative out in front? Or are you squaring the -3? Is that negative going to come along for the ride every time you're writing it? Plus 18 minus 5. So what does that give me? +9 minus 5, which is 4. So 3, 4 is my vertex. 2, 3, 4. Next step is to find my y-intercept. Y-intercept is super, super easy, right? So my y-intercept occurs when x equals 0. It's always 0 something. If I look at my function, it's just going to mean that everything with an x disappears because x is just 0. It reminds me of cover-up method from finding x and y-intercepts, right? Back with linear functions. So I get a -5. Go on my y-axis. Before I'm even done lifting my pen, count 1, 2, 3 to the axis of symmetry. So duplicate that on the other side. 1, 2, 3. Now I'm ready to factor. The factoring for these examples 3 and 4 are going to be a little trickier. So the first step to factoring, always, 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 is to take out my GCF. I can't double bubble with a negative out in front. you must pull out a negative as part of a GCF. You have to, because I cannot double bubble with a negative out in front. The only way I go straight to the double bubble is if it says x squared. Not negative x squared, x squared. So I'm pulling out that negative, which means the negative x squared is now a positive. The 6x is now a negative 6x, and the minus 5 is now a plus 5. Again, imagine distributing back in that negative. Would you get back what you started with? Right? Every sign has to change. That's what factoring out a negative means. So now I'm ready to double bubble that result, right? This is what I'm double bubbling. Negative comes along for the ride, but it's not playing a part in what I'm doing. So x and x, two numbers that multiply to 5, that's easy peasy. 5 and 1 is the only option. We warned you, careful of that 5, 6 combination, because where the 5 and 6 are, it changes the whole makeup of what numbers go in there and where they go. So just something to think about. This is the number they have to multiply to, 5. So it's got to be 5 and 1. They have to be the same sign, and they have to add to a negative 6. They need to both be negative. Negative 5 times negative 1 is positive 5. Negative 5 plus negative 1 is negative 6. Set each factor equal to 0. Again, you can set that negative GCF equal to 0, but it just dies out. Nothing happens with it. Subtract 5 from both sides, so I get x equals negative 5. Add 1 to both sides, so my x-intercepts are negative 5, 0 and 1, 0. No, they are not, right? I made a mistake. Add 5 to both sides, should be a positive 5 and a positive 1. Now, how did I know I made that mistake? Because I don't know if you saw me. I went to go do it, right? And I was like, wait, negative 5 is all the way over here. So I want you to think about that. If I had an x-intercept over here, how in the world is that parabola? Like, what is going on, right? So you should have a general sense of what the parabola should look like before you even factor. This is where students make mistakes, is in the factoring. So use that to your advantage. My x-intercepts have to be like somewhere in this window. They can't be outside that window because that doesn't make sense. I have to get a U shape. It's not going to zigzag. No way. So I know it has to be somewhere in this general area. So when I saw that negative 5, I was like, I guess I made a mistake. Something's wrong. You should use that the same way I just did to confirm your results. It should visually make sense, right? Again, try your best to get a nice curve in there. Not so much point, but a curve. We're going to do another one, so don't worry. And this one has another GCF, something in front, so that should be good as well. Okay, so I have f of x equals negative 2x squared plus 8x minus 6. So again, a good first step. I'm starting with my axis of symmetry always, so I'm going to identify A and B. A this time is negative 2, and B is a positive 8. I go to plug into my x equals negative B over 2A. Notice I copied that down before I plug in. Interesting, huh? So x equals negative B is 8. 2 times A this time is negative 2. So I have negative 8 over negative 4, which is a positive 2. X equals positive 2 is my axis of symmetry. Remember, you're just putting a dashed line there, not a point. But it does lead me into my next step, which is my vertex. Okay, so my vertex, I'm plugging in to 4x because I know my vertex is somewhere on that line. It's going to be 2 comma something. So I want to figure out what that something is. Replace just my x's with parentheses first. And then plug in a 2 into those parentheses. So again, this negative 2, so this is PEMDAS coming at you. This is -2, and then this is 2 squared needs to be done before you can combine with that -2. So PEMDAS, exponents before multiplication. -2 times 2 squared is 4, plus 16 minus 6. -2 times 4 is -8, plus 16 minus 6. -8 plus 16 is 8 minus 6, which is 2. So 2, 2 is my vertex. Next thing to identify is my y-intercept. My y-intercept occurs when x equals 0. I'm plugging 0 into my function here. Everything with an x disappears, and all I'm left with is that number on the outside, -6. So 0, -6 is my y-intercept. Before I'm done making that mark, I'm counting 1, 2 to my axis of symmetry. 1, 2. Duplicate it on the other side for your mirror image. And now I'm going to factor. So I'm going to copy this down, and then I got lots of room to factor for you. Here's my function, setting it equal to 0, because y is 0 for my x-intercepts. This hopefully looks like 9.4, solved by factoring. First step of factoring is to pull out a GCF. The GCF in this case is a -2. So I'm dividing every single item here by -2. I have to take out the negative because I need to start positive. And 2, 8, 6, they all have a 2 in common. So I'm taking out a -2. What am I left with? X squared, careful here, minus 4x plus 3. If I get that signage wrong, there's no way I'm getting the correct numbers in my double bubble. Right? Now the -2 is still there, but I'm only looking at this trinomial inside to factor further. Multiplies to 3, I only got 3 and 1. Adds to -4, both a minus sign. Solve by factoring means I'm setting each of those factors equal to 0. And solving for x, I get +3 and +1. Remember, your GCF just kind of dies out. You could set it equal to 0, but then that doesn't give you anything. So my x-intercepts are 3, 0 and 1, 0. You just want to be cautious because in 9-4, you stopped here. You said x equals 3, x equals 1. But when you're writing an x-intercept, you must write it like this. 3, 0, 1, 0, right? Let's go to our graph, see if that makes sense. 3, 0, 1, 0. It makes sense. They're not all the way over here. That wouldn't make any sense at all. I have a general idea of where they're going. Get a nice, oh goodness, get a nice curve going. You know I'm not an artist.